Now let us discuss one more small problem on engineering mechanics by Professor Tinko, problem set 2.4, and let us do the solution to 2.55. And the statement of the problem is like this. A hanged square, this is a hanged square, A, B, C, D, A. This is figure M with diagonal BD. BD is one of the diagonals. Is submitted to action of two equal and opposite forces. Look at this point. Here is a force P. Here is a force P. They are equal and opposite in direction. Determine the forces produced in all bars. AB is a bar, BC is a bar, CD is a bar, and AD is a bar. DA is bar number 1, CB is bar number 2, BA is bar number 4, and AD is bar number 5. And this is also a bar from D to B, and then a force P to this side, force to P to this side. So there are, if you look at, there are 4 concurrent points, A, B, C, D. 4 concurrent points A, B, C, D. But if you look at point A and C, the number of forces are less as compared to point B and D. So let us apply the free body diagram to the points where the number of forces is less, that is at point A and point C. Let us begin with point A. Now, due to this force and due to this force, this bar will be under extension. So let it be S4 is to this side. So in this bar also, this bar under this force is under extension. So S5 will be to this side. The tensile force S4 and S5. So I have drawn the free body diagram here. Taking this as x-axis, this as x-axis, this as x-axis, and this point, this vertical line as a y-axis, the free body diagram is drawn. So S4, S5. So let us apply sigma x is equal to 0. S4 is to this side. So and the sum of the forces along x-axis has to be 0. Look, there is no force on this side to oppose it. So therefore S4 has to be 0, then only sigma x will be 0. Similarly, apply sigma y is equal to 0 along y-axis. There is only one force, S5, so that has to be 0. Now, if you look at the point C in the original diagram, the C is exactly symmetrical to A, and this one, this bar, due to this force, will be under extension. So S1 will be to this side, and due to this force, the bar CB will be under extension. So the tensile force will also be away from the point to this side, let it be S2. So as we applied the free body diagram at A, similarly if you apply at C and take sigma x is equal to 0 and sigma y is equal to 0, your S1 is equal to S2 and both are equal to 0. So C is symmetrical to point A, therefore S1 is 0, S2 is equal to 0. Now let us apply the free body diagram at point B. At point B. Now I have drawn the free body diagram, and how I have taken the axis. This line as x-axis, and I draw a line like this passing through point B as a y-axis. So that is what I have shown here. So your x-axis, y-axis. So if you apply sigma x is equal to 0, and look, P is opposite to S3, where S3 is the tensile force in the bar BD, So because the bar BD is under expansion, so the tensile force will be away from the point B if you consider point B. It will be away from the point D if you consider the point D. So applying sigma x is equal to 0, your S3 is equal to P, and it is a tensile force.